Hello again. We're going to continue looking at solving simultaneous equations. Topic comes up GCSE and to A-level. And as I said before in my previous couple of videos, we're going to look at the notation, the row notation that they use in OCR further pure 1. We have two equations, 7x plus 3y equals 25 and 5x minus 2y equals 22. Now let's set it out the way they do in further pure 1. We're going to refer to each of those as row 1 and as row 2. Now the aim is, in any other way of setting out, of solving simultaneous equations, regardless of the way we set it out, is to eliminate one of the variables. Now look how we show our working here. I'm going to get rid of the y's. I'm going to get 0y. Now the way I do that is I'm going to alter row 1. So row dash 1 is going to be equal to 2 lots of the previous row 1, gives me 6y here, added to 3 lots of row 2. 3 lots of minus 2y, when added to 6y, will give me 0y. So let's do this in our head. So we've got 2 lots of whatever's in row 1, added to 3 lots of whatever is in row 2. 2 lots of 7x is 14, 3 lots of 5x is 15x, add them together, we get 29x. 2 lots of 3y is 6y, 3 lots of minus 2y is minus 6y, add them together and we get 0y, they cancel each other out. And 2 lots of 25 is 50, added to 3 lots of 22, which is 66, 50 add 66 is 116. So that's my new row 1. My row 2 is unchanged. Now, so I've got one row that contains no lots of one of the variables, in this case y. What's my next step going to be? Well, obviously I'm going to try and get rid of the other variable. Now it's looking a bit tricky here, isn't it? So what I'm going to do is I'm going to multiply, I'm going to alter row 2. At the moment row 1 has got not lots of y. So I'm going to try and make row 2 look so that it has no lots of x. So if row 2 equals 29 lots of x, 29 lots of, I've got my notation here. So a new row 2 is going to be 29 lots of previous row 2, take away 5 lots of row 1. That way the coefficients of x will be the same, and if I subtract them, they'll disappear. So I know I've got 0 lots of x. That looks like it's getting complicated here, but let's have a look what happens with the y's. 29 lots of minus 2y is minus 58y. Take away 5 lots of, we've got no y's here, so I've got plus minus 58y. As we know from GCSE, two symbols that are different without anything between can be changed to minus. Now what happens here? Well, I'm going to have to do some work into the side. 29 lots of 22. 29 times 22. 2 lots of 29 are 58. 20 lots of 29 are 58. 580. Add them together. So it's 638. What about 5 lots of 116? 5 lots of 6 are 30. 5 lots of 1 are 5. Add 3, 8. 5 lots of 1 are 5. Now they've got different signs, but I'm adding them. Oh, sorry, they haven't got different signs, my mistake. So we're taking them away, so it's going to be 638, take away 580, which gives me 58. 638, take away 580 is 68. And now I'm almost done. So just with 2 steps here, alright, there's some working we have to do to the side. We've got, within 2 steps, 2 new rows, one of which has no y's, that's row 1, and the second one has no x's. And my final step would be to make each row contain just one of the variables. So my new row 1 is going to be row 1 divided by 29. My new row 2 is going to be the previous row 2 divided by minus 58. Let's see what we get. Divide everything here by 29. We get one lot of x, or x, plus 0y equals. Now, how many times will 29 go into 116? 6, 7, 7. 140, no, it won't go in 7, it'll go 5, 6, no. Obviously I've got it wrong again. You know what we're talking about. 116 divided by 29 is 4. So there's my final answer. Right, now, gosh, I'll tell you what, the Christmas break away from a bit of maths doesn't half dull in the brain. Now, let's look at another simultaneous equation. Right, so we're going to solve the simultaneous equation. So we'll use the row notation. Right, first step. Let's go for getting rid of the x's. So I'm going to alter row 1. So my new row 1 is going to be equal to 3 lots of the previous row 1, the first row 1, take away row 2. So let's have a look. 3 lots of 3x is 9x, take away 9x, 0x. So I've got rid of one of the variables. 3 lots of 5 is 15, take away 15 is 0. Oh, we came across this in one of our previous videos. 3 lots of 11 is 33, take away 28 is 5. And my row 2 hasn't changed. Now what's the problem here? Well, we've got 0 lots of x plus 0 lots of y equals 5. There are no values of x and y, no pairs of values of x and y, that when you have 0 lots of either, 0 lots of both, it can add up to 5. So we can stop straightways here. We can say immediately say the equations, let's write this a bit more neatly. Just bear with me, I've got too much going on in the background. The equations, that's row 1 and row 2, are inconsistent. Right, well, let's stop. There is no solution. Now, if we stop and think about simultaneous equations, think about them graphically, then when we have a unique solution to a set of simultaneous equations, let's say this was the graph representing row 1 and row 2, then they cross at a point. What about where there's an infinite set of solutions? What are we representing there graphically? Well, what we're representing is that one of the lines, one of the equations shown by a line, row 1, is superimposed over the other. Hence there are an infinite number of pairs of values for x and y that satisfy the equation, the simultaneous equation involving R1 and R2. But what about that last case we just looked at, where it's inconsistent? Well, what we have there is we have two lines that are parallel. and they will never meet, and therefore there will be no solutions. And if we look here, you'll see that 3x plus 5y is a factor of 9x plus 15y, or put alternatively, this relationship between 9x and 15y is a multiple of 3x plus 5y. The fact that they're parallel is shown by the fact that they equal different values, and the different values are not in the same ratio. So where the ratio of x's to y are the same, but the values to the right of the equal sign are not in that same ratio, then the equation will be inconsistent. There will not be a solution.